You can see why we have a lot of enthusiasm that continues to build for what we're doing in our healthcare initiative. The reality of it is that the initiative is almost growing faster and building more than what we're able to keep pace with currently. And so we're excited as we continue to move forward to have more qualified individuals help us as we move this great work. Now, other thing that has really been remarkable to me is not just what we're doing within our own healthcare initiative, but the interest that people have had outside of doTERRA. It's not uncommon to have people come to visit with us and share their own perspective and their own experiences with the essential oils. Some time ago, I was in my office, and a gentleman came into my office and introduced himself as Dr. Jeff Talbott. When I first spoke with him, I thought to myself, well, I'm interested that he has an interest in essential oils. He posed a couple of questions and wanted to know, do we think that there's anything that we could look at with the essential oils that might be unique and that might be different? I listened to him carefully, and it was a pleasant meeting, but at the end of that meeting, I drew to no specific conclusion on things that we would be able to do. To his credit, he persisted. From time to time, as he would come and he would visit in this area, he would drop by my office. We became friends. And he has become somebody that I admire very deeply. One day he brought me some research. He said, after I left your office, I went back and was talking to some of my scientists, and they've already been looking at essential oils. I didn't know they were doing that. I thought I would show you some of the things that they were looking at. In my own ignorance, I suppose, I didn't really fully recognize what he was showing to me. And we continued to speak for several more months until recently it finally dawned on me what it is that he was sharing. For a long period of time, we have wanted to know and understand with essential oils, what is pathway? We know that they're creating benefits for us. We see them, we experience them. We've come to love and to expect them. But because partially of the complexity of the chemistry itself within essential oils, and because in partial amounts a lack of interest in discovering pathway, it never before has been done. In I'll rephrase that. I was going to say earth-shattering. That wouldn't be good, right? In what has become a monumental opportunity for us in doTERRA, with the help of Dr. Talbott and his team of scientists, we now know and understand pathway of essential oils. Never been done before. Now, the first time I visited with Dr. Talbott, he started using terms like proteomics and a number of different things. And this has really been a key to help us unlock what is actually happening with the essential oils. Let me introduce Dr. Talbott to you and tell you a little bit about who he is very specifically. He's the Director of Research for the Center of Substance Abuse and Depression at Roseman University of Health Sciences. Dr. Talbott also serves as the Assistant Dean for Research and Faculty Development at the Roseman University and the College of Pharmacology. He holds a bachelor's degree and a doctorate degree in biochemistry and pharmacology that he actually earned from the University of Nebraska at their medical center. Yeah. He has served as on the National Institute on Drug Abuse Research, and he's a fellow at the University of Michigan Medical School, and as an associate professor of pharmacology at the Ohio Northern University College of Pharmacology. Throughout his career, Dr. Talbott has studied the mechanics and the mechanisms of drug action and drug activity, and their cellular signaling and their regulation, the neuropharmacology and pharmacokinetics of pharmacology. He is the author of more than 70 published papers and abstracts, and he continues to work and writes and contributes to multiple textbooks. Dr. Talbott's research interests focus on psychiatry drug discovery and elucidating biological and behavioral mechanisms of substance use and psychiatric disorders. As you hear his bio, as you learn a little bit about him, can you start to understand why I had no idea what he was talking about? to start to make a little bit of sense. It was such a privilege that not too long ago, as I began to think a little bit differently of what he was really telling me, and I had opportunity to go to Roseman University, where I was exposed to some of the unique scientific process that they have and the capability that they have. And for the first time ever, looking at essential oils and applying technology that previously was reserved for very specific circumstances of medical research. What a privilege it is to have him now partnership with us, here to share his exciting discovery and help us understand more of what essential oils do and the unique differences associated with them in doTERRA. Please help me welcome my very good friend, Dr. Jeffrey Talbott.
Thank you, Dr. Hill, for that kind introduction. And I have to say to all of you, thank you for your warm and personal welcome. I am a first-time conference attendee. Like so many of you, coming to a convention this size for the first time can be a little intimidating, and it can be natural to feel perhaps a little lost, out of place. I mean this sincerely, not here, not for us. This is a true story. Just quickly before I put my science hat on, Dr. Tim Lee, my colleague from Roseman, who will be presenting tomorrow, and much of the work that I'm presenting today is his. He and I yesterday were walking down South Temple to grab a quick bite to eat. At that point, I'd removed my conference credentials, so we were just two random guys walking down the sidewalk. Now, there was a wellness advocate, another attendee, presumably one of you, that was walking down the sidewalk toward us. Without breaking stride and without skipping a beat, this young lady greeted us with a warm smile, a quick wave, and as she walked by said, "Looking forward to your talk tomorrow." It's a very unique feel speaking here. So, to that young lady, if you're out there, thank you for helping me feel welcome. And more importantly, yeah, give her a round of applause, right? And more importantly, I would say and add that she represents what we have come to experience as something unique about the doTERRA family. I mean this sincerely also. I have yet to meet a grumpy doTERRA person. So if Dr. Hill is listening, perhaps it's the oils. But, well, let me slip that science hat back on. I'm going to begin by introducing my institution first, and then our research team. So Roseman University is a private, not-for-profit health sciences institution. We offer accredited doctoral and postdoctoral programs in pharmacy and dentistry and orthodontics. We have undergraduate accredited programs in nursing as well as MBA programs. We currently enroll about 1,600 students from 43 states across the U.S., 16 countries. At Roseman, we have a strong teaching mission with a research focus. Although I wasn't supposed to say this, I will slip in that we are a mastery learning institution. We have a 90% pass-fail, so please listen up because I'm going to give you a quiz when we're done here. So that's my institution. Let me introduce our research team. We're very fortunate to have an interdisciplinary team of scientists whose primary interest is in the development of nutraceuticals as therapeutic agents. Now, this group, if I may, I'm going to brag on them just a little bit, wide array of expertise, including pharmacokinetics, medicinal chemistry, biomedical engineering, biochemistry, and pharmacology. And again, with that sole purpose of advancing nutraceutical science. They came to us, prior to coming to Roseman, this group received training and professional experience from institutions across the U.S. like Baylor, Berkeley, University of Chicago, the University of Michigan, University of Nebraska, Purdue, Stanford, Thomas Jefferson University, and for those of you that are homegrown here, yes, also BYU and Utah, University of Utah. We do not hold meetings on game day. We would get into trouble. And so let me just pause for a moment and say one thing. We are unbiased and independent. We are scientists. Thank you. And what I will share with you today, we have independently verified, and I'll share a little bit more of the background that Dr. Hill shared with you. We have found, we have made discoveries that we feel are both dramatic and significant, and that we believe are perhaps industry changing. What I will share with you is that our data suggests that each essential oil has a unique and singular biochemical fingerprint. That fingerprint, we believe, can be used, can predict the biological activity of the oil and can be used to assess the quality of the oil. Even to the point, as I will show you and Dr. Lee will show you tomorrow, of identifying or detecting adulterated oils. So that's where we're headed today. One last opportunity to brag about our team, just a quick indulgence. Our group has had both national and international media attention because of their research efforts in outlets including Newsweek, the LA Times, Chicago Tribune, Houston Chronicle, the Times of India, the Minneapolis Star Tribune, the Independent, which is in the UK. I think there were some Brits that were here. I heard clap yesterday. There we go. Perfect. What's not included here is over 150 outlets, both news and media across Europe and Asia. We really do feel like we have a very good group assembled. So some of you may remember, at least here in the U.S., a radio announcer named Paul Harvey. He had a nationally syndicated program. Everyone that just clapped is over the age of 40. So one of Paul Harvey's programs was The Rest of the Story. And in this program, he would provide little-known details that told you the story behind the story, and it's really important that I do that today. Our rest of the story in our relationship with doTERRA began 2 years ago in a barn. It was a pretty barn. It's a picturesque farm that's about 40 miles south of here near Mount Timpanogos. At a social event that was being held there, I had a chance conversation with an individual who happened to be a doTERRA representative. Our conversation was interesting and wide-ranging, but ever the nerd, I was trying to pull the conversation back to science to tell him that our research team had been investigating doTERRA essential oils independently, and we had made some discoveries that we felt like doTERRA would be interested in. So, unbeknownst to doTERRA, independently, we went to their website, we purchased a variety of essential oils, along with analogous oils from competitors, and we began to test them in our research models. Here's a couple of examples. We're very interested in the pharmacokinetic properties of essential oils. How is the oil absorbed? Where in the body is it distributed? How is it metabolized? Another project Dr. Hill talked about this morning is On Guard, which I heard a great yell before. Yeah, there we go. So we have been interested in finding nutraceutical effects on biomarkers of oral health. One of those enzymes Dr. Hill mentioned, I'll cover it just briefly, MMP8, matrix metalloprotease. It's a type of enzyme that breaks down connective tissue in the mouth. The lower the activity of the enzyme, the healthier the gums. And indeed, one of our investigators discovered that On Guard is a very potent inhibitor of MMP8. Now, those are just two examples. This last one I'm going to talk about for a moment. I think we all know that, and it's been well documented, that essential oils have antioxidant properties. So we purchased several oils, ylang-ylang, black pepper, and ginger, and utilized a scientifically valid and well-accepted method for detecting antioxidant activity. And sure enough, we found, to no one's surprise, that each of these doTERRA essential oils had robust antioxidant properties. Yeah. What did surprise us is that when we deconstructed the oil and purified the individual major components of the oil, those individual components alone could not replicate the antioxidant properties. Nor was it replicated when we tried to reconstruct the oil, when we took those purified components and synthetically built the oil and put it back together. That didn't work. The last piece of data that came from those studies that sets the stage for today is that the doTERRA competitor oils from other vendors, the non-doTERRA oils, did not also replicate those antioxidant properties. Now, what I've just shared with you are independent observations from our research team and laboratories. At this stage, we'd had no interaction or involvement with doTERRA. But those findings were so striking that we began to think about or hypothesize what we call internally the oil effect. Let me describe to you how we think about this oil effect. Our observations suggest that there are three hallmark characteristics of the oil effect. First is that doTERRA oils robustly stimulate therapeutically relevant signaling pathways within cells that we can detect with scientific methodology. Two, those effects are associated with the whole oil, not individual components. And then finally, three, what's there, it seemed to us in many of those effects were not replicated by doTERRA competitors. So this became the essence of the barnyard conversation that I referred to earlier. Again, we suggested that perhaps there was an interest in working together to explore more. That conversation, as Dr. Hill mentioned, took a little while to occur. But we're scientists and we were intrigued, and so we pushed forward. Now let me just quickly describe the process of scientific discovery is being very earnest and trying to prove yourself wrong, which my wife would say is not difficult for me. You work really hard, you make a discovery, you think it's significant, you turn around immediately and try to poke holes in it and disprove it. That's good science, and that's what we have tried to do. So that brings us to the heavy hitters. Dr. Tim Lee and a postdoctoral research associate, Dr. Yasuyo Urasaki, that works with Dr. Lee. Everything that I'm going to share with you from here on out is Dr. Lee's work. And as Dr. Hill alluded to the best of our knowledge, this is the first of its kind anywhere. So the first goal was to test the hypothesis of this oil effect. Would it hold up to more rigorous testing, to more scrutiny? Now, Dr. Lee, in planning those experiments, realized that a byproduct of those studies would be that he would be creating a biochemical fingerprint for every oil that he tested using proteomic profiling. So let me just describe to you a little bit about this process. So Dr. Lee, for several years, has been utilizing advanced methodologies in a very innovative area of science called nanofluidic proteomics. Proteomics is the study of the large scale study of proteins in the body. Let me put it simply. I'm glad this isn't class. But you can go home and tell your kids or your parents, whichever you are, that you learned some good science today. Simply put, proteins and protein activity is the basis of life. It's what allows us to have health, and protein activity, unfortunately, when it goes awry, is the basis of disease as well. So Dr. Lee, for years, has been utilizing these technologies to study disease states, including diabetes, fatty liver disease, cancer biology. And what we did, Dr. Lee began to apply this methodological approach and innovation to the study of the effects of essential oils on human cells. Now, so how does it work? The explanation is described in the title of this slide. So you just have to be able to read that. Nanofluidic proteomics via high throughput and multiplex capillary isoelectric focusing immunoassays. My dad would call that the nickel description. So you don't have to remember those words. Now, actually, you do. Here's the one instance in which you would need it. The next time you're at a party and you need to get out of a conversation, just drop that. Proteomic profiling by nanofluidic, isoelectric, capillary electrophoresis, and immunoassays. Once the glazed look fades away, people remarkably want to be somewhere else. By the way, I don't know that. That's just hypothetical. So let me just briefly tell you how this works. So this is a robotic system. It's automated. We like robots. They don't get tired and they don't sleep. Basically, what this system does is takes all of the cells throughout the body, throughout proteins throughout cells, and separates them based on size and charge in little micro capillary tubes. Once those proteins are separated, they can be probed. So Dr. Lee will take very, very specific antibodies that recognize very selective types of proteins and even portions of proteins. And it allows him to look for or to probe for protein changes that affect the activity of the protein or the enzyme. Now, there are multiple changes that can occur in proteins that dictate how they work. It's a little like having a gas pedal and a brake on enzymatic activity. You can speed up or slow down, and Dr. Lee can identify those. We call those post-translational modifications. There are many. I'm going to talk about one today called phosphorylation. So this is how these experiments work. We did these studies, Tim and his, Dr. Lee and his postdoc did these studies in human hepatocytes. So these are liver cells. So all the information that we present to you today will be very relevant to the human condition. Those cells are grown in culture, and then Tim applied essential oils for a 24-hour period. This is not a transient response. This is a chronic long-term treatment with the oils. Once that occurs, then using that automated system, we can probe multiple signaling pathways, 3 of which are shown there. I wouldn't expect any of you to remember these, but each of these are very significant, physiologically relevant signaling pathways that affect how your cells respond. Let me just describe 2 things on this very complicated slide. One is each of those pathways you notice has multiple components. It's like a cascade, we call it, so that when the cell responds to a stimulus, like an essential oil, there is a post-translational event that occurs, in this case, a phosphorylation event, that then cascades. It's like tipping over a row of dominoes. That's point number 1. Point number 2 is that the effect, the cellular effect of these pathways can lead to systems-level responses. So, for example, the MAP kinase pathway is associated with cell growth and regeneration and rejuvenation. The PI3 kinase AKT-mTOR pathway is associated with I'm actually going to look at this now. metabolism. And we can turn that on and off. It's important to remember that these are systems that at times and in certain conditions you would want more activity, and at other times you would like less in order to respond to the cellular environment. And then finally, the JAK-STAT pathway is associated with immunity or healthy immune responses. So with that background, let's walk through what these data look like. So this is an example of what we call a chromatogram. And we've used in these, or Dr. Lee has used in these studies, copaiba, treated for 24 hours, these hepatocytes. You see two graphs. Let's just focus on the top one. That top one, that chromatogram, shows different types of enzyme called MEK1 that's part of the MAP kinase pathway. If you focus on the right, that's the unphosphorylated or inactive form of MEK1. You can see that peak there on the top. That's of the control cells. So basically, these are cells that have seen no essential oil. There's lots of inactive form of MEK1. After treatment, what you'll notice is that there is less inactive or unphosphorylated MEK1, and there is a significant increase in the amount of phosphorylated form of MEK1, and that's shown on the left. That's the change that we look for, and that indicates that copaiba increases the phosphorylation state of MEK1 in human liver cells. Now remember that these cells have signaling pathways with multiple components. So we didn't stop at MEK1. Here's data on MEK2. So although the changes are smaller, we still saw increases in the phosphorylated or activated state of MEK2 in response to copaiba in human liver cells. Another enzyme in that MAP kinase pathway, which is called ERK1 and 2. Again, following copaiba treatment, we saw increases in the phosphorylation state of this enzyme, the activated state of this enzyme in response to copaiba. So what does this mean? That when it comes to the MAP kinase pathway, copaiba in human liver cells stimulates multiple levels of that pathway, which tells us that copaiba positively regulates the MAP kinase signaling pathway in liver cells. Now, I'm going to walk through some of these data a little more quickly now because you're all pros at it, right? You're professionals. So that was just one of those three pathways. How about the others? Looking at the AKT, PI3 kinase mTOR pathway, again, in response to copaiba for 24 hours. In this case, we saw a decrease in phosphorylation of AKT, suggesting that copaiba inhibits this pathway. Looking at another element of that pathway, a protein called 4E-BP1, its phosphorylation state similarly decreased after 24 hours of treatment with copaiba. This tells us that copaiba in human liver cells negatively regulates the PI3 kinase AKT mTOR pathway. Dr. Lee continued to look. This is the last pathway, looking at STAT3, which is a significant component. In this case, copaiba after 24 hours increased phosphorylation of STAT3. Now, thank goodness all of you, or some of you, are saying, let's get on to the point and not the data, but we're showing you everything that we have. Copaiba in human liver cells after 24 hours has a varied and complex response on these pathways. Remember that each of them is associated with a systems level response that at times, and under conditions you would want to have less activity, and others you want more. Now, I'll save you us the time. We repeated those studies, or Dr. Lee did, with green mandarin, helichrysum, melissa, pink pepper, and turmeric. And again, you can see a complex picture of very focused regulation, cellular the regulation of cellular activity in response to the essential oils. So this is the beginning of this biochemical fingerprint that each oil has. Now, so the next question that we asked is, what happens if we compare doTERRA oils with competitor oils? And we simply took, for these studies, green mandarin, turmeric, and pink pepper, and we compared them to a competitor's oil under the same conditions and the same assay, looking at the proteomic profiling. And I think you will be surprised, perhaps as much as we were. So let me walk you through this data slide. We're just going to look at the top two rows. The top row are untreated liver cells. And what you'll notice, after 24 hours of green mandarin treatment, there was a robust increase in the phosphorylated state of STAT3. When we performed that study with a competitor mandarin oil, we didn't just see no change. That oil inhibited the same pathway. Now, Dr. Lee is a brilliant scientist, and this got him thinking, what if the effects of that competitor oil resulted from a single constituent? So we know that one of the single constituents that make up green mandarin is limonene. So Tim simply purchased some limonene from a basic laboratory supply company and used it at a specific concentration, and look at that. These data suggest to us that perhaps some competitor oils have been adulterated or even spiked with simply a purified component, which we know does not have the effect of the whole oil. This was just one example. How about the other? This is turmeric, doTERRA versus a competitor. Now we're looking at the MAP kinase pathway. Again, the top two lines. The top row are untreated cells. The second row are cells treated with turmeric from doTERRA. We see a nice, robust response, as we expected, in the phosphorylation state of MEK1. The competitor inhibited the activation or phosphorylation of MEK1. That effect was mimicked by just straight aromatic turmerone, which again, in our hands, suggests that perhaps competitor oils have been adulterated or spiked. They lack the same biological activity than the doTERRA oil. And finally, a third example, pink pepper. On the PI3 kinase AKT pathway, you're looking at AKT states of phosphorylation. The pink pepper inhibited AKT phosphorylation. The competitor had no change, no effect. Again, that was mimicked by treating the cells with alpha-pinene. So this is kind of a summary slide that I think you can pay attention to. If you look at just the top table with green mandarin, the doTERRA effect of the oil is very, very different than the competitor oil. And to us, what was striking, perhaps even stunning, is that the effects of the competitor oil could be replicated with simply concentrated aromatic, a single constituent. And of course, that was replicated with turmeric and pink pepper. So I have just a couple of moments. I'd like to summarize some of the data that we've talked about. Now, again, the purpose of these advanced studies by Dr. Lee and Dr. Urasaki was to further test the oil effect. And we believe that his data suggest or give credence to this oil effect hypothesis that we've had. Again, that doTERRA essential oils, the whole oil, has robust, physiologically relevant effects on human liver cells. Also, that the effects of that oil cannot be replicated by a single constituent. And importantly, that third bullet, we now know more than we did before, that essential oils from different companies had minimal or opposite effects on cellular regulation. If you were in one of my classes, teaching Doctor of Pharmacy students, I would say this next slide is my last slide, and you would applaud because you're ready to go. But this is one that I think is particularly important. These are the significance and implications of Tim's work in validating the oil effect hypothesis. One is that quality of an essential oil is the combination of chemistry and biochemistry. To say it differently, biochemical analytics are really required to fully assess the quality of an oil. Let me say it even differently. I know in this industry there's a great deal of effort to disguise adulteration of oils, presumably for cost purposes. You might be able to disguise the chemistry of an oil, but your cells know the difference. That is the implication of Dr. Lee's studies. In that sense, your cells are really the perfect lie detector test from a biological activity standpoint. The implication of that is therapeutic potential. We believe that these data, we believe, suggest that the therapeutic potential of essential oils is highly dependent on the composition, which means that sourcing, processing, and characterization efforts are absolutely key to move that work forward. And lastly, qualitative assessment. We feel like this advanced instrumentation approach is a new way to assess, a rapid way and a new way to assess essential oils from anyone.